Welcome back. Let's dive into Unit 2, where you'll learn how to implement your own agentic workflows using your chosen framework from your Unit 1 assignment, OpenAI Agents SDK or Crew AI. By the end of this unit, you'll be equipped to design, build, and run AI agents that can work together to tackle real-world challenges. First, let's talk about the OpenAI Agents SDK. This is a framework that helps you build multi-agent workflows by leveraging large language models, also called LLMs, that understand human language. Simply put, an agentic workflow is a process where AI agents carry out tasks and make decisions without human interference. Think of them as a team of smart assistants who collaborate and solve problems on your behalf. The Software Development Kit, abbreviated as SDK, has a basic structure that comprises three main elements. Each agent is an LLM equipped with instructions and tools designed to help them complete their task. Handoffs can come in two main types, hierarchical or sequential. In a hierarchical structure, a triage agent assigns tasks to specialized agents. In a sequential structure, where one agent's output feeds into the next agent. An example would be a research agent passing its output to a summarizer agent that answers the user's inquiry. Lastly, guardrails are structures that help ensure security and privacy, often in the form of try-catch structures that run in parallel with the agents. Agents are the cornerstones of your project. They are made up of three main components: instructions, models, and tools. As mentioned in the previous unit, instructions control how agents behave. Please review the prompt engineering section to get an idea of what you should include. By default, the SDK uses the OpenAI responses model, but you can also integrate with Light LLM to use non-OpenAI models if you wish. Hosted tools such as the Web Search tool and File Search tool are built in for the OpenAI responses model, but you can also customize your own by using Python functions or other agents as tools without fully handing off the task. Another integral part of multi-agent workflows is handoffs. This mechanism allows agents to delegate tasks to one another, passing along context and instructions based on responsibilities and capabilities of other agents. Handoffs enable seamless teamwork between agents, optimizing the efficiency of the workflow. You can add information about handoffs in the instructions using the recommended prompt preferred from the handoff prompt module. This ensures each agent knows exactly what to expect from the handoff process. Agents also need context to work effectively. In the SDK, they can come as local context or LLM context. Local contexts are data and dependencies only available within your code. This could be a Python object, like a data class, or a Pydantic model, wrapped in a run context wrapper when passed to function tools. The LLMs behind the agents cannot access local context. The only data they can reference is the conversation history. To make new information available to the LLM models, you should use LLM context. This includes modifying instructions, appending the context to the input object, or passing new context through function tools. An important thing to note is that every agent in a single workflow must use the same type of context to keep everything consistent. Next, let's talk about keeping your agents secure and reliable using guardrails. They're like security guards that run on the initial user input and the final agent output, checking whether the input or output is appropriate and accurate. Keep in mind that input guardrails only run on the first agent in the workflow, and output guardrails only run on the last agent. If a guardrail fails, the SDK raises an exception, either an input guardrail tripwire triggered or output guardrail tripwire triggered, depending on the decorator you use for your guardrail function. This prevents errors or unwanted behaviors from propagating through your workflow. The SDK also supports tracing, which records everything that happens during an agent run and helps you debug. This encompasses tool calls, handoffs, guardrails, and more. Each of these mechanisms is called a span. To access data stored in spans, such as LLM generations and function calls, you can call generation span and function span, respectively. Finally, to run your agents, you'll need an OpenAI API key. You can get one by signing up at platform.openai.com. Don't forget to set it as an environment variable on your system for privacy, or use the set_default OpenAI key function in your code as a temporary solution. For this project, we'll use the default API to run our agents, so you will not need to specify that variable. That's a solid foundation with OpenAI Agents SDK. Next up, we'll dive into Crew AI, another powerful framework with its own tools, flow system, and memory features.